Assalamu alaikum wa rahmatullahi wa barakatuh. We'll continue, inshallah, with our revision for Unit 1, Forces and Motion. The second topic we studied in this unit, the difference between distance and displacement. What is the difference between distance and displacement? As you know, distance is a scalar quantity and it measures the total path, while displacement is a vector quantity. Always when we talk about displacement is from where we start to where it ends. Here I have a question to illustrate the difference between distance and displacement. I need to find the distance traveled from point A till point C. So how can I find the distance traveled from point A to point C? Add all of this number. I have from A till B is 3, plus from B till C is 5. So the distance traveled from A till C will be 8 meters. The distance traveled from A till D, from A till D. From A till D, I can go from A till B, which is 3, plus from B till C, which is 5, plus from C till D till I reach the end point D, which is 3. If I add them together, 8 plus 3, it will give you 11 meters. Or I can go immediately from A till D, which will be 5 meters. So I have two answers, either 11 or 5 meters. The other question, what is the displacement from A till D? Here displacement, we said, is a vector quantity. I have to specify the direction. So it will be 5 meters, 5 meters. I'm going from A till D, so it will be right. What is the displacement from A all the way around back to A again? I went to A and I get back to the same point. Vector quantity from where to start to where it ends. I start from A, I end at A, so it will be 0. 0. If the question, for example, I can add, what is the distance from A till C? This distance. What is the distance from A till C? I can add this question, from A till C. From A till C, I can go 5 plus 3 will give me 8 meters. This is the distance. How about the displacement? How about the displacement from A till C? I start from A, I end from C. So from where we start to where it ends, this will be the displacement. How can I find the displacement? I can use Pythagoras theorem. Pythagoras theorem will be 5 square. I have right triangle, so first leg square plus second leg square, which is 3 square. And you will get the answer if we calculate this one. 5 square plus 3 square, you should get 5.8. 5.8 meters. You see the difference? Distance and displacement, they're not always the same. Sometimes they give you the same value, but not always. Okay, here I have another question for you. Compare the displacement of a traveler who travels by car from Dubai to Al Ain, and the displacement of the same traveler, or could be another one, but this time he travels from Al Ain to Dubai. So Dubai to Al Ain, suppose it's let's say 5 kilometers, 500 kilometers, whatever the distance is, and the other one goes from Al Ain to Dubai. Al Ain to Dubai. I'm talking about displacement. It's a vector quantity. So it should be the same, but in opposite direction, because displacement is a vector. I have to specify direction. So should be the same. They're equal displacement, but they are in opposite direction. Opposite direction. The other concept we studied, velocity. What is the difference between velocity and speed? Velocity, it's a vector quantity. Speed is a scalar quantity. If I go from Al Ain to Dubai or Dubai to Al Ain and I need to specify the velocity, I have to calculate the number and specify the direction. So velocity is displacement over time. Displacement over time. Displacement, as we know, is change in position over time. I can memorize it this way. I can say the velocity will equal delta V or V average equals change in position, x final minus x initial, the final position minus the initial position, divided by change in time. Change, it means the difference. T final minus T initial. If I need to find the displacement, delta x will be velocity times time. Velocity times time. If I need to find the time, will be delta x on the top divided by what? By V average. V average. What is the unit? Always I get the unit from the formula. The unit for displacement, SI unit, is meter over time second. So it will be meter per second. Speed, if I'm moving, for example, from Dubai, from Al Ain to Dubai, so I have to specify the direction. The value, the number, plus the direction. This is velocity. Speed, no. Speed, I give the value. So the average velocity is the total displacement divided by the time interval during which the displacement occurs. Speed, on the other hand, has no direction, only magnitude. How can I find the speed? Distance, because it's scalar quantity, so it will be distance over time. They have the same unit, distance, meter times second, so it will be meter per second, and we use the speedometer to indicate the speed in our car. We have a question. You have a man travels at speed. When you have a question like that, first thing you have to read the question, understand it. Second, you have to write the given. Check whether all the units are consistent. What do I mean by consistent? If all the units are in SI unit, so I don't need to convert. If they're not, in this case, like I have, for example, meter, SI unit, and another unit for time is hour, in this case, I have to convert. Make them all the same SI unit. If all the units are in Gaussian system, CGS, C for centimeter, G for gram, mass in gram, S for time, all of them in this system. So I keep them all. I should have consistency in the unit. All the units should be the same. So first I have to write the given. The average speed, so this one is V average, 28.1 meter per second. Along 8,000 meter, it's a unit for displacement. So I have displacement, the symbol for displacement, delta x. So delta x is 8,000 meter. I need to find how much time does the man take to travel this distance. The symbol for time, delta t, I don't know. Now you remember this triangle. Here on the bottom, I put average. On the top, I have displacement and t. So do I need to convert? No. I have here meter. Here I have meter second. So all the units are consistent. SI unit. I don't need to convert. So we wrote the given. We check the units. Now I start solving the problems. Write the formula and substitute. So delta t will equal delta x on the top divided by V average. Divided by V average. Delta x is 8,000 divided by V average 28.1, and you get the number here, meter per second, and here sorry, here meter, and here meter per second. Meter and meter, they cancel. The unit, it should give you second, the final unit, second. So if I calculate this number, I have 8,000 divided by 28.1. It's around 284.7 second. Or I can round it to 285 second is fine. Okay, second thing, the other thing also we studied is the graphs. We studied position versus time graph, velocity versus time graph. If I give you a position versus time graph and I ask you find the velocity from this graph, always velocity is the slope. How can you find the slope? Rise over run. Rise, rise, over run. Over run. Rise is the vertical distance, run the horizontal distance. Here, position, it means the change in position divided by change in time, because we know average velocity change in position divided by change in time. Here in this example, what is the value of the velocity? Rise, it will be 8. 8 minus 0. 8 minus 0. This is this distance. Divided by run, it will be 8 second minus 0. So 8 divided by 8 is 1 meter per second, because distance is meter, time second, meter per second. Here, if I give you different lines and I ask you which one of these lines will have the highest velocity. Highest velocity, it will be the steepest slope. Steepest slope here, this one is the steepest slope, the green one, and this one is the steepest slope. You can check yourself. Find rise for the green one, over run. Rise, 50, over run, 2.5. You calculate it for the green. You can check. Rise, which is 50, over run, it's around 2.5. And check for the red. Check for the red. Rise, which is this distance, rise, 50. 50 minus 0, 50. Overrun, over 5. We can check. So 50 divided by 2.5, it's 20. So here the slope, 20. And here, 10. So the highest speed will be the green. This one will represent the highest or the steepest. So always the steepest line, or the line with the steepest slope, will give you the value of the highest speed. Highest speed. If the line is if you have distance versus time graph or displacement versus time graph and the line is vertical, I don't have a change in the position, so the displacement in this case is 0. The velocity in this case is 0. The velocity is 0. Similarly, here the velocity is 0, but the object is behind the observer. Here I have line that's going up, increasing, so that I have a change here in the position. Since we have a change in the position, here we have velocity, so the velocity here is positive, and it's constant value. Constant value, it means same value, doesn't change. Same speed all the time, it's constant. If it's moving down, the object is moving towards you, and same thing is constant speed, but this time it will be negative speed. There is a nice simulation here for fit simulation. We already did this one in the class. I can put the position, for example, at 5. Start recording. Here you see the object is not moving. I can change his position to 5, click enter. I can change it again to -5, click enter. So here he's not moving. Here he went back, he went left. Here is not moving. I can put him back again to 0, for example. You see, he's moving to the right. Positive speed. Now he's not moving. I can bring him to, for example, 10. So still he's moving right.